Well, hello everyone. Today we will be learning, actually conquering, logarithmic. Need to find some pens. Actually, they're markers. I don't know why I keep calling them pens. Logarithmic differentiation. So we have here. First thing you want to do. So basically, you may think to yourself, "Oh wait, I have to do product rule and then chain." Actually, quotient rule and then product rule and then chain rule, and then a bunch of quotient rule and product rule and chain rule, and then use substitution and this substitution. Well, dear, my friends, all my calculus people, you don't have to do that. We can solve this by logarithmic differentiation and make our life a little bit more simple. So I'm going to show you this example and maybe another example if I'm feeling like it. So here are some logarithmic properties. Pause, I'm going to stare at them. I will explain them. So if log sub b, m times n, these are the basics, equals log sub n, log sub n, okay, I can't even talk, log sub b of m plus log sub b of n. Now and then in the second one, just random, log of b all over m over n equals log of b, log sub b. I don't know, I just get them mixed up. But anyway, you get it minus this and this, basically log sub b to log sub b of n to the n to the p power equals p times log sub b times n. This just gets carried down here. This just gets carried down here, and then basically you have this. So we're going to apply these properties to this and then differentiate it. So first thing I want to do is we're going to take the ln of both sides. So we'll do that. I wonder if this works. No, it doesn't work. This doesn't work either. Okay, time to get new ones. Alright, so we're going to take the ln of both sides. So we'll have ln of y equals ln of 2x plus 1 plus, we can change this square root to a 1/2, and it'll be 1/2 ln x plus 9, because since we're applying ln to both sides, this and this gets involved, and then minus 7 ln times x plus 5. Yep, like that. So let's just sort of do it like that. Okay. And this is what happens. And then now this is the point where we differentiate this. So this here will be y prime all over y equals, we'll do we'll do chain rule, so it'll be 1, because 1 over 2x plus 1 times 2, because then we derive this, it's just, once we derive the bottom here, it's just 2, because we just, did chain rule, plus 1/2 times 1 all over, this 1/2 stays, don't turn it to 0, it stays, 1 all over x plus 1, x plus 9 times 1, because we differentiate the bottom here, minus, we can just put this in parentheses because we're going to distribute this in the end, minus 7 times 1 all over x plus 5 times 1, and you don't need parentheses, you get, we differentiate x plus 5, it's just 1 because, 5 is 0, constant. Same with this one. Please do not differentiate the 7, it's just sort of like a thing that's outside. Don't differentiate and think it's 0, it's because it's not. This is, leave it out. And so now we're going to make this cleaner since we already differentiated this. So to make it cleaner, I'm going to put y prime over y. Well, actually, you know what? You see this y here? I don't like it here. So we're going to multiply both sides by y. And in the end, we'll have left, and what I mean by the y, I mean this is now going to go back down here. So it'll be 2x plus 1 times the square root of x plus 9 all over x plus 5 to the 7th power times, this 2 goes on top, so it'll be 2 all over 2x plus 1, 2x plus 1 plus 1 all over 2x plus 18 minus 7 all over x plus 5. And this is your final answer for this one. So as you can see, what we did here is that I don't like this. So we already redifferentiated this, and it turned out to be like this. And I don't like this y prime over y fraction here. I don't like it right here. So I took it out. Let me see if you can see this. That's what it looks like. Okay, I don't know what I'm doing. Anyway, this is how it looks like. And basically, yeah, so it's y prime over y prime. And y prime over y, and I just don't like this, y are down here, so I'm taking it out. So I multiply both sides by y, and basically you take this, your original equation, and you put it over here, this y area right here, you can see. And so I'm feeling a little, I want to do another one. So I'm just gonna erase this, and I'm gonna do another simpler one. So yeah, just gonna take a towel. I don't have a dry erase marker. I lost it. Just gonna erase this. Alright. So another problem we will be doing is y equals x to the x. Now please don't freak out and say, oh my god, I can't do it, because you can't. Using these properties, you can do it. So, I don't want to put it over here. I'm going to put it somewhere else. I'm going to put it in the middle here, y equals x to the x. So the first thing you're going to do is take the ln of both sides. So we'll do that, ln of y, and then x ln x. Here, we're going to do product rule, which is f g prime plus g f prime. Here, we'll do product rule. And here it's just we're going to differentiate this. So when we differentiate this, it'll be y prime over y. And now, so this is f and this is our g. So f times g, the derivation of g, which is ln x, which is x times 1 over x, plus g times f prime, which is ln x times x, the derivation of f x, which is just 1, so ln x times 1. And basically we're going to solve this. So it'll be y prime over y equals x. This cancels, so it's just 1 plus ln x. And then after that, we're going to multiply both sides by y, because get rid of it, I hate fractions. And so in the end, we'll be left with this beautiful equation. Does this one work? Okay, this sort of works, sort of. We're going to be left with a beautiful masterpiece, which is just, so this, of course, going back to this y gets put back into here, so then you'll have x to the x all times 1 plus ln x. So this is the answer to this beautiful thing right here. And I love throwing things. And this is how you do logarithmic differentiation. So don't freak out when you see a problem like this, because remember, in pre-calculus, your teacher taught you these things, or you should, well, you should know them. Well, after watching this video, you probably know them by now. So, yeah, don't do chain or product rule and then chain rule and then quotient rule, because then you'll be left with this many you'll be left with at least, how many pages? 1, 2, 3, 4. You'll be left with 5 sheets of pages to do. And I don't think do you want to waste your whole life doing that? Do you want to make your life simple and do this in like 5 minutes? These 2 problems, well, just go back, were simple because of these properties and a little bit of differentiation, a little bit of log this, log that, little chain rule. We did a little bit of chain rule there, just a little bit, not too much. Well, actually a lot of chain rule, but not as much as you will do with. Well, basically, don't do quotient rule. It was there. Don't do quotient rule, then product rule, then chain rule, and then quotient rule and product rule and blah, blah. Don't do those. Just make your life easier by doing logarithmic differentiation. So I'm gonna go now. So I hope you now conquered I hope I conquered all your math problems today, and I hope you can like and subscribe and comment down below what math problems I should do next. But until then, I hope you actually, you know what? I hope now I've conquered all your math problems. So, bye.